All right, you guys ready to start? So our first speaker from Container Solution, Ian Crosby. Please welcome Managing Director.
We're going to be talking a little bit about architecture, so specifically looking at monoliths and microservices and serverless. But I'd like to start with a quick story. This is about a project that I worked on a little more than a year ago. And we had a client who came to us, and they had this really cool piece of technology, this piece of hardware. And they were very excited about it, and they asked us to build a platform for this. So essentially, this piece of hardware was going to collect a bunch of data, would get fed into a platform, do some machine learning, and then solve all kinds of different business problems. So they were really excited about this, and I got really excited about it to kind of design this thing really ideal, and it's completely greenfield. So I got to try and design the ideal architecture, right? So of course, everything's microservices from the start. Everything's containerized. Everything's running on Kubernetes. Fully distributed cloud-native platform. And we're going along for a while, kind of getting near completion of this platform. And then we have a meeting with the client. And they say, hey, we've got some good news. We actually found another company that wants to use this platform. And it's kind of like, I guess that's probably a good thing. Somebody actually have the customer. They're like, yeah, so can you take that platform you built and run it on one of their standalone servers inside a private closed network? And kind of a moment of frustration, I think, went from my face in seeing from there we kind of spent a week taking this beautiful distributed cloud-native architecture and shoehorning it to run on this single server with no internet connection. But the lesson I eventually took away from this was that there is no ideal architecture, right? We had this beautiful greenfield layout, full kind of rights to create anything, and we designed this very nice-looking architecture, but there was no business case behind it. There was no proper use case yet, so there was no real point to it. So this was kind of a lesson that I learned, is that it really depends on your context, depends on your use case, and there needs to be some kind of business case behind it, or else your architecture doesn't really matter. So talking about architecture a little bit, I think this is kind of a tricky term that we use a lot. We've obviously taken it from another domain. But one of the problems with it is that you think of architecture from buildings. This is work which is mostly design work, which is done up front. Everything's done by certain laws, and then handed off to another company to maybe go and actually build it. And then the architecture is essentially static for the entire lifetime of that building. But more and more, this is really not how architecture works in the software world, right? Things change. Architecture has become more of a continual process where we need to be able to adapt. It's not something that we have a committee that sits and defines the architecture for the next 5 years, and we'll meet again in the next 5 years to do it again. So if we can't use this metaphor anymore, then how do we try and define software architecture? And I went searching for a proper definition somewhere, and the one that I like best this is from Martin Fowler. He's actually quoting Ralph Johnson. So it's about the important stuff, right? Whatever that is. And it's kind of a funny definition in ways, but I think it's actually quite relevant. Because architecture, if you want to boil it down, it's about the important decisions in your project. These are the things that you want to get right up front. And the second part, this just implies that it's different from one case to the other. You can't define a set of architectural rules that are going to apply everywhere. It depends, again, on your context and on your use case. So we have had trends, however, which we can kind of see looking back, where from the mainframe days, everything was running on one big box. We moved to more of a client-server architecture. Then we kind of moved into 3-tier, into microservices, and so on. And you see this trend of breaking things down into small. So if we look at a trend like this, we could be forgiven for coming to an assumption, something like this, right? We had monoliths, okay. Then we came up with microservices, and this is better. And then from there, we have serverless, so things get broken down even smaller. So this is even better, right? Well, essentially what I'm saying is that this is not necessarily the case. Each of these different types of architecture have their flaws, have their advantages, and they go with different use cases. So I want to quickly look at each of these and talk about what are some of the advantages. Now, of course, there are many different types of architectures out there. This isn't the only ones. But I think these are the three main terms that we tend to use these days. So if we talk about monoliths, right? Again, this is a bit of a broad term. So if we try to define it, a monolith essentially is, it's everything running as a single piece. More importantly, it's about the deployment. So if when you're deploying your system, your application, and everything has to be deployed together, you more or less have a monolithic architecture. And there are different types. The most standard is, a single process. So everything is run as a single process, say in a jar file, for example. You can have modular monoliths with different modules inside. You can actually have a very well-architected monolith. Or you can have a distributed monolith where, yes, we've got all these different pieces, but again, there's so much coupling going on, we have to deploy them all together. So essentially, we still have a monolith. So these are terrible. Monoliths are bad, as we all know. But that's not necessarily the case, right? There are some advantages. They're very quick to build. So if you're starting from something from scratch, it's much easier to start with the monolithic style architecture. If you have a small team, these are the quickest way to get something built, get something working. And it doesn't necessarily have to be ugly. Monoliths are probably more performant, right? If I have this nice microservice architecture, for example, all of these calls that are going across networks, running on different machines, how does that compare to something that's just making function calls in process? This is obviously going to be a lot faster. And simple for some definition of simple. At least in terms of conceptualizing your architecture. Of course, one piece is much easier to understand and comprehend than is dozens. So again, there are use cases where a monolith makes sense. If I'm building a POC or a prototype, for example, or maybe I only have a small team, I don't know if it makes sense to jump into something like microservices right away. But monoliths can be a very good fit. So talking about microservices for a little while. So if we try to define this, I'll not do this myself, but I'll let Sam Newman give a definition. So he says microservices are independently deployable services, which are modeled around a business domain. So there are certain things which we come to expect for microservices. They are small, hence the name. They're composable, as it takes many of them to build into our actual application. They should be resilient, fault-tolerant, scalable, etc. And of course, there are drawbacks to microservices, but there are also some very strong benefits. We end up with a much more flexible design, a flexible architecture. Right? If I need to change something out, I can just replace a single microservice instead of impacting the whole application. If I need to add functionality, similarly, I can do that. If I want to choose a different technology, I have much more freedom to do that with a microservice. It's easier to scale. So if I have a monolith, for example, and I'm starting to hit some bottlenecks, I'm getting more traffic than I'm used to, then if I want to handle that, I need to scale this entire system, so I need to run another copy of it. But of course, with a microservice, if we can identify where that bottleneck is, I only need to scale that one specific piece. And again, kind of looking at the whole Conway's law sort of thing, microservices lend themselves much better to larger organizations with many more teams. Whereas, I can assign a microservice or several to a certain team, and then they can own that specific domain. They don't need to have a depth knowledge of the entire system. So again, there are use cases, just as with monoliths, where microservices are a good fit. The most common use case, or the best use case I see, is usually where people start with a monolith, and then somewhere along the lines, they start to hit some of the kind of thresholds, and then it makes sense to start looking at moving to a microservice. In most cases I've seen, starting with microservices from scratch is generally not the best idea. So then we have serverless, of course. This is a nice serverless data center. I thought I was really original when I made this joke. Turns out it's been made many times online. So if we try and define for a second what we mean by serverless, and I'm focusing more on the function as a service piece. Again, I'll let somebody else give a better definition than I will. So Mike Roberts says this is about applications where we're running logic inside stateless compute containers, which are event-triggered, ephemeral, and fully managed by a third party. So trying to break this down a little bit, we can see that this idea of stateless ephemeral containers. This kind of forces certain design on us, right? We can't assume that our applications are already going to run in the same place, that they're going to have access to the same data. So this kind of enforces the way that we design our applications. Event-triggered, so this fits into certain use cases where we have asynchronous tasks, or if we're using message queues, we have an event-driven architecture. Again, serverless might be a nice fit. But most importantly is fully managed by a third party. And this, of course, is the whole serverless aspect of it. Yes, there are servers somewhere, but the idea is that those are somebody else's problem. I get to focus on writing my actual business logic. And somebody else is responsible for keeping those up to date, keeping those alive. So look at some of the advantages of serverless. Cost savings is one of the ones that's thrown out quite a bit. This whole idea of you pay for what you use. So if nobody's actually calling my API, I don't get charged for it. And this is not just in terms of your cloud bill at the end of the month, but this could be just in terms of CPU memory resources that you're using, if you have an in-house serverless platform. Again, this idea of invisible infrastructure, so that it's somebody else's responsibility to keep these machines up, to keep them all the configuration there. Again, I get to focus on my actual application. And security, again, with a little asterisk. The idea is that security is, again, moved more towards this third party. And we're assuming that they're doing a good job there. But basically, as an application developer, there's less damage that I can do in a serverless model. I have less access to do harm. So, of course, there are certain use cases where we can think of where serverless is a good idea. If we think of event-driven architectures, this might be a good fit. If we want to run different kind of asynchronous tasks, maybe we're doing some machine learning jobs, etc. These would be good options for serverless. So, we started off with this premise that there is no ideal architecture, right? That it depends on the context. And we saw how the three of these, monoliths, microservices, and serverless, have their own different advantages. So we're kind of left with a choice. How do we choose which one is actually the way to go? And again, you have to look at your specific use case, look at what your context is, try and map it to these pros and cons. But it's also a matter of, it's not either or necessarily. Any medium to large style system is going to have at least two of these styles of architectures in there. We're going to have some kind of a blend. And in terms of trying to design an architecture from the beginning, there's some good news and some bad news. So the good news is that, this is not forever. Like we said, this is not, the days where we have architects sitting in a room and they're going to decide our architecture for the next 5 years. So this takes a little bit of the pressure off when it comes to designing the architecture. It's not going to last for the lifetime of your company. The bad news is that this is also not going to last forever. We can't just do our architecture, wipe our hands, and say, we're done, see you in 5 years. It's something which needs to be done continuously. And similarly, you have to think about how change is going to impact your architecture, because change is going to happen. So this is not some new idea that I'm trying to present here, right? This idea of change coming. There are some common, or some ideas out there which I want to highlight, which are all around this similar idea. Michael Nygaard, who wrote the really great book, Release It, he has some talks online. He also does some workshops called Architecture Without an End State. And essentially, he talks about specifically in enterprise architectures, this famous 3-year plan that they come up with to implement a new system, and how this is inherently false and it never works, because there's change that comes. It could be technology, it could be just business decisions in terms of we're shifting priorities, people will change. So these things never succeed. And we need to take more of an iterative approach to our architecture and be a little bit more flexible. Similar idea as the concept of evolutionary architecture. And there's a really great book, Building Evolutionary Architectures, by Neil Ford, Rebecca Parsons, and Patrick Kua. And they talk about this similar idea of architectures needing to evolve and need to change. And there's some very practical examples in there of how to build these styles of architectures. They have the concept of what's called fitness functions, where essentially these are like validation tests that can run against my system and decide that as change comes, is my architecture improving or degrading in the way that I want? So this is how they move away from the idea of random evolution, but what they call guided evolution, to make sure, again, we're heading in the way that we want. And I think this same idea also fits into the whole kind of cloud-native aspect, right? I mean, if we step back from the buzzwordy side and the specific technologies, cloud-native is about building systems, building applications that are meant for the cloud. So this means we can take advantage of the things that we have, such as, infinite compute resources, but also handling the issues that are there. It's this idea that things are going to break, that we're no longer in control. And essentially, we're building systems which are meant to handle change, systems that are resilient, and ideally that are anti-fragile, and that they should actually improve with the chaos that's out there in the cloud. So the common thread here, I guess, that you're seeing is that the only constant thing is change. So we need to be able to adapt to this and to understand that our architectures are something which we need to be able to do throughout the life cycle. So there's a couple ways when we talk about changing our actual architecture. One of the common approaches is this idea of the big rewrite. We had this big monolithic system. Microservices is a new cool thing, so we're going to throw out what we had and replace it with microservices. And I've yet to see this actually succeed. First of all, I don't know that many companies who can afford to take 6 months off delivering features and rewrite things. But in general, I don't know if this is the right approach. The idea, again, is that we want to be able to do things incrementally. And this is a concept we've kind of adopted already in the software world, right? The whole idea of continuous integration, continuous delivery, delivering value quicker, bringing down risk sooner. So this is the same principles, essentially, which we want to apply to architecture. Experiment, iterate, and constantly improve. So the way that we want to look at it is more of like a continuous migration that we're doing. There's no final destination at the end, but we're kind of continuously migrating, continuously improving. And to try and get things a little bit more into a practical sense, there's approaches that we tend to follow. So imagine we have a monolith, and we want to move to maybe microservices or serverless. We find the piece, find the seam, the piece that we want to actually replace. We pull it out of our old system. Maybe we rewrite it in a new language as a microservice, or maybe we just take the existing one. Then we redirect our traffic, and again, there are tools out there which can help us kind of do intelligent traffic shifting. Maybe we leave the old one in place for now. And then we slowly monitor things, right? We shift our traffic over, have a good monitoring system in place that we can see, hey, have things improved, have things degraded, should we keep going? And then finally, once the old piece is no longer in use, then we just repeat this process. And again, this should be done in kind of an experimental fashion, right? Where, we have a hypothesis that pulling this specific piece of logic out and replacing it as a function is going to bring down our cost or going to improve performance. So we go through a quick experiment, test it out, have the data to validate if this is the case or not. And if our hypothesis is disproven, then we can go back. But again, we want to keep this kind of learning mindset in experimentation. So I'd like to do a kind of a quick demo of this because demos always go well and never go wrong. So I have an application here. It's a little bit more than a hello world, a little bit more involved. This is kind of the logical flow of what's going on. So we're ingesting images that would be theoretically coming from different cameras. It's going to do some facial detection to see if we have any actual faces in these images. It will then create some encodings, and it's going to take those encodings and search against our database to see if we have any known people in there. If we have a match, then that's cool. We'll do some notification. Otherwise, maybe we'll update our database and store some additional information. And then we have a small UI that's going to show this. So again, if I'm building this from scratch, maybe it doesn't make sense to start with a fancy modern architecture, but let's start with a monolith, right? This is the quickest way to get something built, get something going. So we have a fairly simple, high-level architecture to start with. Our big monolithic backend, a small front end, and a database. So let's jump over and see if we have this running. Is that readable? So even though it's a monolith, we're still going to run things on Kubernetes because, come on, it's 2019. So I've got a cluster up in GKE. You can see I've got 3 applications running my database, my front end, and my monolithic back end. So let's go see if we can check the UI. As you can see, I am not a UX designer by any means. So we've got a small load test, which is essentially going to simulate images kind of coming in from cameras. So we're going to run some load tests, send in some things in, and hooray. So we see that, okay, here are some faces which are being recognized. Timestamp identifies an ID for the person and a location. And okay, so this is, this was a good way to get started, right? We built the system fairly quickly, and we've got something working. But then we start to run into kind of some limits. Okay, we start getting this thing in production, and things are going well. We're getting more and more traffic, and our system can't really handle this at some point. You'll have to take my word for it because I actually knocked over the cluster when I increased the load too much. But trust me when I say it can handle a whole lot of traffic. So how do we solve this? Well, we can, I can run another separate instance of this whole application, or maybe I can, look at what's actually happening. And you can see that it's actually the encoding piece, which is actually very CPU intensive and, taking a long time. So what I might want to do is, pull this piece out and replace it with a microservice. So again, let's go through this kind of standard process. We find the seam, so in this case, it's my encoding service, which I want to pull out. I'm going to replace it with a microservice and redirect my traffic. So my new architecture would look a little bit like this, very similar, but we just have this face encoding piece, which we pulled out. So let's give this a try. So I will deploy. So this is just going to deploy the new service, which I built, which is the encoding piece. And also a new version of the monolithic backend to actually call this new piece. So now if I see what's running, we see we have an extra service here, this encoding, which is now running, and then you can see that the monolith is updating to the new version. So now if we go run our load tests, ideally what we should see is, from the user perspective, is nothing, right? The logic hasn't changed. This should be still the same thing going on. But the benefit now is that as I have this piece separate, if I want to start scaling, what I can do is actually just scale this one piece instead of the entire application. So let's increase this load a little bit. And that's how you increase load. You just reduce sleeps, right? Because this is very advanced. So we'll give it a little bit more load, see if we can actually handle it now. So we can see the events are coming up a little bit more frequently at this point. And again, because I pulled this other piece out, we can scale this separate piece on its own without having to scale the entire. So we actually see what I didn't show, what was actually deployed was a horizontal pod autoscaler, which is something we get in Kubernetes, which is just going to scale it on its own. So you can see, I didn't actually have to do the scaling myself, but it sees right away that it needs more versions of this encoding service, so it's going to scale that on its own. So these are kind of the freebies that I get in running with this new architecture. So I think we can call that fairly successful in terms of starting to integrate microservices here. But what if we want to keep going? So obviously there's different use cases where we might want to migrate our architecture. What about if we want to add new logic? For example, I want to add an alerting piece so that if I actually find a notification, if I match somebody's face, we want to send in alerts, send those into Slack because that's where all important information goes. Again, I could build this into my existing monolithic application, but I've already seen that this is hitting the limits. This is kind of an asynchronous logic, so maybe this might fit for a serverless model. Again, one of the important things for a serverless is that you want to have a platform already available. You don't want to have to write your own. But because I'm running this, again, on Google Cloud, on GKE, what I can do is use Google's Cloud Run, which is essentially a hosted version of Knative. So this is a serverless platform which runs on top of Kubernetes. And then I can just deploy my application just as my new service, just as a function. So the new architecture, again, we're just adding this one piece for alerting, which we're just going to deploy in a serverless model. So let's see what that looks like. So the first thing I'm going to do is just update that monolith to a new version, which this new version of the monolith is going to trigger my new function. But now I need to somehow actually deploy this new function, right? So what I'm using, it's difficult to see, but I'm just calling Google Cloud's CLI. And all I'm saying is I'm giving it a Docker image, which is my new application. So all I have to do is write the Docker image, and I'm pointing it to my existing Kubernetes cluster that exists. So that's all I have to do, and then essentially it will take care of the rest. It will create all of the pieces which I need. It'll make sure that it's actually already available to everything running in my cluster. I don't have to wire anything up by myself. And then it'll take into account that this application is running, and whenever it gets triggered, it'll spin up new instances. So then the idea is, now that I have this new piece of logic up, we rerun some load. Every time that we actually get a match, if it matches a face, it should trigger this new service. And again, the idea here is about running these as kind of experiments and iterations. So instead of just throwing everything out and rewriting it as microservices or rewriting it as serverless, we can do these things in small experiments. I can pull out the pieces as necessary to rewrite this as a microservice if that's the model that fits. I can introduce a service and at the same time kind of experimenting if this is the right model. Because what we usually end up with is some type of a hybrid architecture, right, where it's a combination of these three. This usually does things a little bit faster, but that's okay. Time tends to slow down in live demo world. You can always go to the UI and see what's happening. This lets me give you a lovely tour of the Cloud Run UI. So it is trying to create my new service. Oh, so the logs say it's actually up and running, so we're going to believe this is actually up and running. So let's just trigger some load and see what happens. So again, if we go back to our UI, from here we should see more or less the same thing. Again, this is just still sending encodings, it's seeing people are there. But now if we get any actual matches, there should be a notification somewhere. If the routing traffic ever comes up. This is what happens when you do the same live demo twice in a week, is that if it works the first time, by rule, it's never going to work the second time. I'll come back to this in a second and see if it ever gets up and running. But again, the idea is that the lessons we want to take away is this idea of an ideal architecture, right? This doesn't exist. The architecture that you want to build depends on your use case, depends on the business context where you're involved. So don't just think that, hey, we now have serverless, this is the best architecture, but look at the actual options that are available to you. And even once you have defined it, your architecture is going to change. Technology changes very quickly, the business direction changes, so you don't want something that's static. You want your architecture to be flexible, to be able to change. And to do this, we just want to iterate and experiment, right? Try out new things, come up with an experimental kind of mindset, so we have a hypothesis, run it as an experiment, check the data, and go forward if it succeeds. If not, be prepared to go back. And so these are kind of the main things that I think we need to take into account in defining architecture. So, thanks.
Thank you, Ian.
Still routing traffic.
So we have a kind of a small rule here. We can't ask the questions because we have a speaker table at the back. So the speaker is going at the back, and if you want to chat with him, you have all half an hour to discuss things and how it goes. Just because we have a lot of talks, we don't want to interrupt on the talks. So I want to thank Ian. Ian is actually working hard organizing DevOps Days Montreal, I think, right?
Yes.
So there's another big conference that is coming to Montreal. We wish you all the best, and thanks for helping us today, and cool. Good luck, Container Solutions.
Thank you.
Yeah. So our next speaker is actually coming all the way from Boulder, Colorado. Anybody went to Boulder? Okay. I just went there for onboarding on the GDG. We had our academy. It's fantastic, very nice mountains, very hot there. But Niraj is actually working on the cool technologies with Istio, and he's one of the co-founder of the company called Aspen Mesh. Anybody heard Aspen Mesh? Okay. Anybody heard F5? Okay. All right. So this is very, very close. It's kind of a startup based on the, I think, on the F5.